right, so here got the notes for transformations, functions, reflections. Reflections are relatively straightforward. So a reflection is a transformation that maps each point to a new point across a given line, which is referred to as the line of reflection. So we'll do the two of them today. Reflection across the x-axis, so g of x equals negative f of x. So if you reflect across the x-axis, so that's going to be top to bottom, it's the y values that will change their sign. The points won't move horizontally, so the x values remain the same, but the y's become opposites. Just remember that negative y here doesn't mean that this y value has to be negative. It just means that it's the opposite of this y value. So if this one's negative, that one's the opposite of that, or positive. You can also have reflections across the y-axis, which is written like this in function notation. This across the y-axis would be right to left. So that means the x values will change their sign. The y values should remain the same. Just like above, negative x doesn't mean that this x must be negative. It just means it's the opposite of the original x. So kind of similar to translations, if your negative sign is out front, it's going to be x-axis reflection, left to right. Or sorry, top to bottom. If it's inside, it's a horizontal reflection, so across the y-axis. So this would be like if the negative was inside the absolute value bars, underneath the square root, things like that. You'll have a mirror across the y-axis. Okay, so we'll look at our examples. So our first one, negative cube root of x. So this graph is the graph of the cube root of x. So negative is out front, which means it's a reflection across the x-axis, so every point mirrors top to bottom. So the y values all change sign. So this point that's currently at positive 2 would now be down here at negative 2. This point that's at positive 1 is now at negative 1. This point would be up at positive 1, and this point would be up at positive 2. So the graph is just mirrored top to bottom. That was really bad because I missed the point there, but right general idea. Okay, so the second one here, so this negative x is inside of the exponent. So this is going to mirror the graph, what was it, left to right? So, yep. So that's an example of this one, inside, be across the y-axis. So every point flips the sign on its x. So this point that's currently at positive 1 would now be at negative 1. This point that's at positive 2 would now be at negative 2. This point that's at positive 3 would now be at negative 3. Then the graph, so it's going to be a mirror across the y-axis. Okay, so 3, your negative sign out front, so that's going to be a top to bottom flip, so everybody goes upside down. So this point that's at 4 is now at negative 4. Negative 3 becomes, or sorry, positive 3 becomes negative 3. 2 becomes negative 2. 1 becomes negative 1. 0 obviously doesn't move because the opposite of 0 is 0. We come just back down the other side, with every point being the opposite of the one it was before. So the graph is mirrored top to bottom. Okay, so number 4, this is inside, so it's going to be a right-left. We're going to mirror the x's. So this point that's at positive 1 will be at negative 1. This point that's at positive 4 be at negative 4. This point that's at positive 9 will now be at negative 9. So this graph is going to point that way instead. And our last one here, so once again inside, so mirror right to left. But for this graph, it doesn't do anything because the points are already mirrored. So this point would move over here, but then this point would move over here. So the graph is already done. That graph is its own reflection. You can't reflect the absolute value of x across the y-axis because the x values happen to be the same. And that's the end of the section.